Hey y'all, Miss Harper here for our lesson 2, multiplying polynomials. All right, so we are jumping into our exponent rules, or as I like to call them, exponents rule. Get it? I'm sitting at my desk right now waiting for the laughter to happen, so make sure you're laughing out loud, LOL. All right, so you're going to be taking notes on your own sheet of paper. So we know what exponents are. X to the third power we have here. The 3 is the exponent. All right, so I would probably make note of what's the exponent versus the base. So we call this thing the base, and we call this thing the exponent. All right, so exponential form. So exponential form is this, the condensed version, shorthand version, x to the third power. Remember, that means x times x times x, and that's what we call expanded form. All right, product of powers. Remember, product means multiplication. So the product of powers for any number a and all integers m and n. All right, so this is the official rule you'll want to write down. This is the multiplying rule. So anything that has the same base, so for example, if we had x to the second power times x to the third power, it equals x to the m plus n, meaning we add our exponents here. And in a moment, I will show you why we add the exponents when we are multiplying our bases. All right, so let's do a couple practice problems. All right, so x to the second, oh, coincidental, I just showed y'all that one. All right, so let's break it down. I'm going to put it into expanded form to help you better understand why this is happening. So x squared, well, that equals x times x, right? And then we're multiplying it by x to the third power. Well, that's x times x times x. So if I were to put this all together, this equals x to the fifth power, which is why when we multiply things of the same base, we add their exponents, okay? So whichever version makes sense to you. If you want to write this expanded form out, if you need to do that initially while you're going and practicing these things, while you're getting started with these, you can do that. But eventually you'll start to understand the rule here and you will just be better at adding these things. Now, our exponents have exponent rules, but our regular numbers still have the same rules. I mean, normal, regular rules. So for example, here, we have a 2 times a negative 3. So our whole numbers will multiply together, and then our like bases will multiply together. So I'm going to handle the 2 times negative 3. Well, that's negative 6. All right. Now, if it helps you, this is x to the first power. So now I'm going to multiply my x to the first times x to the third, and that's going to become x to the fourth power. And again, if you'd like to see this in expanded form, that's 2x times negative 3x times x times x. All right, so again, like terms play together here. So our 2 times negative 3 gets us that negative 6, and then we have 1, 2, 3, 4 x's. All right, and again, that's what we would call the expanded form. Our official answer here is negative 6 x to the fourth power. All right, so why don't you pause the note video and try out numbers 3 and 4. See how you do. And then whenever you unpause the video, I'll have the expanded form and final answers shown for you. All right, so if you're back with me, hopefully you got these final answers. And this one. And again, you can see the breakdown of the expanded form. 3nn times 4nn. All right, we count all those things. We have a total of 6 n's. And then our normal 3 times normal 4 is a normal 12. All right, this one looks a little hairier. Again, only things they have to have the same base in order to apply those exponent rules. So like our a's and our a's will play together, and then the b's and the b's will play together, and then our normal numbers and our normal numbers will play together. So negative 3 times 3 is where we got the negative 9, and then I see I have 2 a's here, another a here, so a total of 3 a's, or a to the third power, and then 1, 2, 3, 4, 5, 6, 7 b's, b to the 7th power. High five yourself if you got those right. All right, I would probably pause the video and write these things down. So we have the power of a power rule, okay, or we just call power to a power. All right, and what we do with power to a power is we actually multiply those. All right, power of a product. We'll look at one of these. Again, power. It's kind of a power to a power rule again. We kind of distribute this exponent here and here, and we'll look at some examples. So write these rules down, and then the power of a monomial you see right here too, okay? So write those down, pause the video, and then continue on with the next examples with me. All right, so let's look at some of these. So now I have power to a power rule. So again, let's break this down into expanded form. So this is x squared times x squared times x squared, right? X squared to the third power. It's being multiplied 3 times. We could break this down even further. That's x times x times x times x times x times x. All right, so this is where the rule comes in. It says that we multiply these things. So this is where we end up with our final answer of x to the 6th power. 2, 4, 6. We have 6 total x's. All right, so hopefully that expanded form is helping you to understand how these rules apply. All right, looking at our next one. Now this is where you gotta be careful, okay? This little exponent, again, how we distributed him up there, he gets distributed to all the powers up here too. All right, so that's our power to a power. So this is -2 to the first power right now. I don't like writing that right there. But again, this is -2 to the first power. So if I did, so this is going to end up becoming -2. 1 times 2 is 2. All right, and then x to the third times 2. Again, we're kind of like distributing that sign or that power. So in your calculators, if you don't know, you can do -2. Oh, actually, you need to make sure if you're playing with negative numbers, you need to put them in parentheses, -2 raised to the 2nd power. And we see that's +4 because -2 times -2 is +4. So this ends up equaling 4x to the 6th power. All right, looking at it again in expanded form, this is -2x to the third times -2x to the third. All right, we could break it down even further, -2, x times x times x times -2, x times x times x. And hopefully, again, you'll see -2 times -2 is the +4, and then we have 1, 2, 3, 4, 5, 6 x's. All right, so if breaking it down into expanded form helps you out as you're learning and processing these rules, please do that. All right, again, power to a power. It's kind of like you're distributing the power to the powers, and we do that by multiplying them. All right. So this is going to be x to the 6th power and y to the 4th power. Again, expanded form would say x to the third, y to the 2nd times x to the third, y to the 2nd. All right, and then again, I can break this down further. Expanded form, this is x times x times x, y times y times x times x times x times y times y. All right, so we see we have 6 x's, which is where we got that, and then 2 and 4 total y's. So we end up with x to the 6th and y to the 4th. All right, you don't have to show the expanded form every time. I'm just trying to break it down so y'all can have a better understanding of why we have these rules and how those rules work. All right, this one's going to be a little hairy, but why don't you try to pause your note video and see what you can do here. Pause the video, attempt number 4, and then you can resume and see how you did. All right, so this one was nasty, okay, but high five yourself if you were able to get here to this answer, okay? You can pause this note video and kind of look at both of the ways that I did this. So one way is over here, I distributed the 3 to everybody. The biggest mistake that I see is kids forgetting to distribute it to this 2, all right? So that's a base 2, and we still have to distribute our exponent there. So that's where we got 2 to the 3rd, a to the 4th times 3, because I distributed that, and b to the 1 times 3. All right, I simplified that here. All right, and then looking over here. So what I did was, this is -2b to the 3rd power to the 2nd power. So I just wrote this out 2 separate times. And then I handled that 3. Oops, I kind of put this one in the wrong spot. This 3 was supposed to be out here, but hopefully you know what I mean. All right, distributed that 3 in there. So -2 to the 3rd power. Again, be careful. Make sure that you're using your parentheses. -2 raised to the 3rd power. And that's a -8 because it's -2 times -2 times -2. All right, so I get -8 b to the 3rd, -8 b to the 3rd, and then I just used my product rule and I multiplied everything straight across. 8 times -8 times -8 is 512. My A's didn't have anybody to play with, and then my B's all got multiplied together, and whenever we're multiplying things of the same base, we add their exponent. So I had 3, 6, 9 of those. Okay, or I kind of did a less formal, like less expanded form. So I first just distributed my 3 everywhere. So I ended up here, 2 to the 3rd power is 8, a to the 4th times 3 is a to the 12th. And then b to the 3rd, we got that b to the 3rd there. All right, now here, this is the one of y'all's rules. I forget which one it's called, but it's like the a product power rule or whatever it is. But basically what we do is we end up multiplying these two exponents together, 3 times 2, and then distributing that 6 to everybody. So this is, and again, you saw the breakdown over here, but this would become, we multiply these two numbers, so it's -2 to the 6th power, and then b to the 3rd power to the 2nd power. So again, we multiply those, and that gets us b to the 6th power. And then I took it a step further here. I did 8, or this just dropped down, all of the same stuff. Now I simplified this. -2 to the 6th power, you can pop that into your calculator, and you see it's 64. B to the 6th power, and then 8 times 64 is that 512. A to the 12th stays chilling. B to the 3rd times B to the 6th is that B to the 9th, okay? That one is a lot. These are a lot of work, okay? Let's try out, see if we have anything else left over here. And nope, that's actually it. So again, work through these problems, check yourself, raise your hand, come ask me questions. There's going to be a partial key posted on the board. These things can be really tricky. And again, if you're really hung up on one, try to expand it. Put it into expanded form and really try to see the breakdown of what's happening. Holler if you have any questions.